In this AstroPictionary Physics math, we would like to solve Newton's second law problem. So I drew Newton's second law up here, up in the right for you. It's sum of the forces is equal to mass times acceleration. Sometimes you'll see it written as sum of the forces or net force is equal to mass times acceleration. We're given a horse and a jockey have a combined mass of 100 kilograms. So they're already telling us what the mass is. So we're given mass is equal to 1,000 kilograms. Dynamic friction of 200 newtons acts on the horse's hooves that opposes the 700 newtons of applied force by the horse to accelerate the pair. So we're given a force of applied, and that is going in the positive direction, and that is 200 newtons. No, that's 700 newtons. And then we have the opposite direction, which is the friction. Friction always acts in the opposite direction. So we have the force due to friction. So friction always acts in the opposite direction of motion. So it's negative 200 because I declared up and to the right as positive. So to the right is positive, which is the force of the applied, but friction always goes in the opposite direction. So that direction in the x direction is negative. So hence I put a negative symbol in the force of friction. It says A, what is the net force? So we want to find A, net force, or sum of the forces. And then B is we want to find the acceleration. So the equations are already given to you at the top. And so let's solve. So the first thing we want to find is sum of the forces. Let's go ahead and write in Newton's second law. And whenever you're using Newton's second law problems, you want to solve either on the left-hand side or the right-hand side first. Since we are not given acceleration, but we're given mass, we really can't solve the right-hand side. So let's work on the left-hand side, which happens to be part A. It says sum of the forces, and all you just do is sum them up. And that's F1 plus F2 plus F3, etc., etc. So we have FA going to the right, so it's 700 newtons. And then we're subtracting, because we have a negative, 200 newtons. And then we just solve. 700 minus 200 is just 500 newtons. And that's still going to the right, because it's a positive value, and I declared right to be positive. So that's my answer. That's my net value. And now I'm on to B. B is find the acceleration. Well, that's I just used for Newton's second law. I substitute 500 newtons in for the left-hand side of the equation. 500 newtons. And I'm going to go ahead and put my units in. 1 newton we know is a kilogram meter per second squared. So I'm just going to go ahead and replace them. Instead of putting newtons down, I'm going to put a kilogram meter per second squared. That is equal to the mass, which we know is 1,000 kilograms. And then we multiply, and we have all this by acceleration squared. Oh, acceleration. F equals ma. So we have to divide both sides of the equation by 1,000 kilograms so we can isolate acceleration on the right-hand side. So 500 divided by 1,000 is just 1/2. And we have on the right-hand side, let's go ahead and eliminate numbers and letters. We're just left with acceleration on the right-hand side. So now we need to work out the letters. Well, we know kilogram and meter are in the numerator, so let's go ahead and put them in the numerator. And then we know this second squared is in the denominator. Now we have this one. 500's in the numerator, 1,000's in the denominator, so a kilogram's in the denominator, so it goes down here. Now we get rid of like values or like letters. That's kilograms, and we're left with a meter per second squared, which makes sense because we are solving for acceleration. So we're left with 1/2 meters per second squared, and that's our acceleration, and we need to put a direction down. Since the value is positive, that means we're accelerating to the right. Let's check it. Well, that makes sense. Our horse and jockey are going to the right. We should have an acceleration to the right, and that's my answer. So that's how you solve an example of Newton's second law type problems.